The last topic in this chapter is considering interaction between independent variables. Okay. If you have more than one independent variable, you can possibly consider how two variables interact to produce an effect on the dependent variable y. So here we have two variables x sub 1 and x sub 2. Now to assess the interacting effect of x sub 1 and x sub 2 over y hat, we can multiply the two and use this column, multiplied values of x sub 1 and x sub 2, as a third independent variable. So this third independent variable is derived from the values of x sub 1 and x sub 2. So here then is the effect of interaction model, beta sub 1 x sub 1 plus beta sub 2 x sub 2 plus beta sub 3 x sub 1 times x sub 2. Okay, and then you have the y-intercept and the error term. So without the interaction term, the effect of x1 on y is measured by beta sub 1. Okay. Now without interaction, the effect of x sub 2, effect of x sub 1 on y with interaction is measured by beta sub 1 plus beta sub 3 times x sub 2. The effect of changes. So the effect on y, the interaction part of the effect on y changes as x sub 2 changes. If x sub 2 changes, then the interaction effect on y also would change. So here is an example in a graphic in a graph format. Okay, suppose if this is the regression equation, so this is what the two lines will look like, giving you as x sub 1 increases, okay, and x sub 2, the effect of x sub 2 increases as x sub 1 increases. Okay. If there is no interaction, then you would expect these two lines to be parallel, but it is not, so that means there is an interaction effect. So let's look at an Excel example. So let's look at the house assessed value example. Okay, so dependent variable is assessed value, and the independent variables are the size of the house, okay, and whether the house contains a fireplace or not. Now, if to see whether there is an interaction effect, we can define a third variable as the product of x sub 1 and x sub 2, and then we can test whether beta sub 3 is significant or not. So here our data is represented in these two columns. So area, whether fireplace or not. Okay, so now we define the variables. Y is the assessed value, x sub 1 is the area, x sub 2 is whether there is fireplace or not. Okay, 1 is yes, 0 is no. And then x sub 3 is the product of x sub 1 and x sub 2. So our multiple regression model will look like that. Okay, you have three x's, so you have x sub 1 and x sub 2, and x sub 3 is the product of x sub 1 and x sub 2. So our multiple regression equation will be of this form. So we have three slope coefficient estimates. Of course, you have b sub 0 also. So to estimate these values, the b values, we have to have one more column for x sub 3. So this is our x sub 3, which is the product of these two. So we go x sub 1 times x sub 2. Okay, we set that up here. Okay, so now we have x sub 1, x sub 2, and x sub 3. Now we can run the regression with these three columns as our X range. So regression, our Y being the same, but the X range is going to be X sub 1, X sub 2 and X sub 3. And let's put the output over there. Okay, so now here are the estimates: B sub 0, B sub 1, B sub 2, B sub 3. Okay, so now we can test for overall significance. Overall significance p-value is from the ANOVA table. So the regression is significant. Now for individual significance, so the p-values will come from, for beta sub 1, okay, so there is your first X variable, that's the p-value, and then if you copy that down, the rest of them. So this is the first p-value is less than 5%, so we can say this is significant, and then not significant for the remaining two. If you want to come up with estimates in the case of interaction effect, so let's go back to the previous example. Okay, the first example we saw was predicting Y. Okay, first let's assemble the coefficients. So B sub 0 here, and then B sub 1, 2 and 3. Okay. Alright. So for the first case, when there is no fireplace and we are still considering 2000 square feet, okay, and with or without fireplace, okay. So in this case, X sub 1 value is 2, X sub 2 is 0, and then we multiply X sub 1 with X sub 2 to get the X sub 3 value. Here it is 2 and 1, and once again we multiply X sub 1 and X sub 2 to get the X sub 3 value. Now Y hat is B sub 0, absolute reference that, plus, now we want to multiply these three coefficients with these three X values and add them up. So we can use the function sum product to accomplish that instead of going pair one by one, which can be cumbersome. So we take all the three slope coefficients together, make that absolute reference, and then the three corresponding X values, and that will achieve the same thing as before. So this is how you will apply the interaction regression equation for predicting Y value.